Okay, today we're going to have a look at conjugate theorems. So there's many different conjugate theorems, and unfortunately it's useful to know all of them, although they are quite easy to prove if you have forgotten them, but they are very handy just to know. Number one is that z times z bar, which 100% this one you need to remember. Z times z bar is the modulus of z squared. Number two is if the modulus of z is 1, then 1 on z is equal to z bar. This one, need to memorize this one as well. Z plus z bar is 2rez. Conjugate of a sum, a bit of an unusual one, which is quite useful, especially with the complex roots of unity. If we add something together and then take its conjugate, it's the same as taking the conjugates of them individually and then adding them together. And another one we've got to remember is z minus z bar is 2 times the imaginary component of z. And last one, very similar to the difference, the conjugate of a sum. The conjugate of a product said is we take a product by timesing a series of complex numbers together and then take the conjugate. It's the same as taking the conjugates first and then timesing them together. So the proofs are very, very easy. You just have to each time replace z with x plus iy, do some simplifying, and we can see, for example, that that first one is very easy. So if z is equal to 3 minus 4i, find z bar. Now, the theorem for this is that z bar is equal to the modulus of z squared. The modulus of z is the square root of 3 squared plus 4 squared, which is 5. So z bar is 5 squared, which is 25. Nice and easy. If z is equal to 1 on 2 plus root 3 on 2i, then find 1 on z. Now our conjugate theorem states that if the modulus of z is 1, then 1 on z is just simply the conjugate of z. So if we actually look at this, yes, the modulus of this is 1. Root 3 on 2 squared is 3 on 4. And 1 on 2 squared is 1 on 4, and 3 on 4 plus 1 on 4 is 1. So yes, that is true. Well, that means then 1 on z is equal to z bar. So this is 1 on 2 minus root 3 on 2i. Okay, I'll do a couple more. These are quite straightforward. Find z plus z bar. Z plus z bar is equal to 2rez. Do you have to state these? No, they're assumed to be true, especially this one here. That's just going to be 6. Z minus z bar is 2mz, which is minus 8i. And we might do, this is the last example anyway. If p and q are the roots of this expression here, find p bar plus q bar. Well, p bar plus q bar, well, we know that that's the same as p plus q bar, and p plus q is just the sum of the roots. So it's just going to be the sum of the roots is minus 1 plus I over 2, and we're just taking the conjugate of that. So it's minus 1 on 2 minus 1 on 2i bar, which is minus 1 on 2 plus 1 on 2i. And then p times q is the product of the roots, which we know to be 10 minus 3i on 2 bar. And we also know that p bar times q bar is the same as pq bar. So this is 5 minus 3 on 2i bar, which is 5 plus 3 on 2 bar. Okay, that's it. Thanks for watching.